In the previous lesson, we learned to design the earth mat based on IEEE method, and in this lesson we will learn to design the earth mat based on finite element method. So to do so, I will double click on the earth mat over here, then I will select the finite element method over here and click on OK. So now we will go into the ground grid system, and let me change this over here. This automatically updates the surface material resistivity and so on. Then I will click on OK. Then I will go to the edit mode over here, and in the edit mode on my right side, this time I will find several conductors, rods and some shapes. So I will select a shape over here, then let me resize the shape. I will change the grid size from here, and as before we can change the conductor depth, the size of the conductor, the type of the conductor, the cost of the conductor and so on. And I will put in some rods. Okay, then I will put in some conductors. So using the finite element method, we can design any shapes we want to, because there is no restriction on the shape as in the IEEE standard, and we can place the conductors with unequal distances as well. I can also place this in several angles. Okay, let's try to simulate this. So I will go to the ground grid study option over here, then I will go to the edit study case, and now as you can see, the method has been switched over to the finite element method, and now we do not have the optimization function over here and everything else. I have not updated my short circuit study, so I will put this in the user specified fault current. Then I will click on OK, and let me conduct the calculations over here. Okay, so after the calculations, this has found that the system is actually feasible because the tolerable volts are greater than the calculated volts. So in the finite element method, the advantage is that you can design any shapes you want. And let me go to the plot section over here. So I will plot the touch voltages, step voltages with the over voltage limits. And here we have, so the step potential profile is as shown over here. So the step potential is very less at these points over here and is very large at these red colors over here. I will close this. Then the touch potential profile. The touch potential profile is also shown over here. The touch potential is also somewhere around 100, 350 to 400 or 100 to 150, I suppose. And this is the absolute potential profile over here. So after conducting my analysis, we have found that everything is well within limits. So everything is well within the limits. So let me close this option over here. Then we will go to the report generator and we will generate the input data. Okay, this time we have only used the user defined data, so the total fault current is 2 kiloamps, and we have the conductor data over here from what coordinates we are drawing and the length of the conductor and the cost per feet. We also will have the total cost over here. So let me go and update my fault current over here. Going to the single line diagram, then I will conduct the short circuit study and update this fault current. I'm sure this time this will not stay within the acceptable limits. So I will go to the edit study case, short circuit study. Okay. And now you can see, which I suspected, that the maximum touch voltage exceeds the tolerable limits. And let us go to the plots option over here for the touch voltage alone. And now you see we have voltages in the range of 1600. So this is not a very good design, and we can change the shapes if I want to, but it's better to use the IEEE 80 standard. We can only use this finite element method if we have any specific requirements. Either way, we could design the ground grid using the IEEE 80 method or the finite element method. It actually depends upon the project you are working on. So this is how you conduct a earth-mat design using the finite element method in Etap, and see you in the next lesson.